Uh, yeah, Coffee Compiler Club. Here today to talk about compilers and language runtimes and Thanksgiving leftovers. And they're being recorded and it shows up on YouTube in a couple hours. And today I want to start with a demo I've been working on the last week. That's of simple as a graphical demo. And these things have an infinite amount of love you could do to them and make them better and better and better. But this is a clean, a reasonable start to a demo. So let me hit the share button and I'll go backwards and forwards and we'll discuss this thing here. So this is launched by saying the make file, make view. Java, you're just launching JS viewer. I'm going to go to the source code for a second and show you how to launch. So chapter 18 is the branch. It's functional. It doesn't have functions, but the branch functions. So JS viewer, you has a main. You just run the main with no arguments. Yeah, here's more people coming in. Hey, Matt, Adrian. Yeah. So I have this viewer for simple. It's called JS Viewer. It's in the top source level of chapter 18. You have to switch to chapter 18 branch. Go to chapter 18, find JS Viewer. Just run the JS Viewer, Java space, com, C of node, simple JS Viewer. And it pops up and give you this window, which has a return 0, and you're going to put your program here. I'll change this to return 1 plus 2 just to be different. And when I click outside this box, it'll load. And at the bottom down here, this will start counting up. That's the number of unique frames I'm going to show you. And I've got 17 frames loaded, of which the first like 5 are all tied to just the parser starting. Bigger program put down hundreds of frames. But this guy is pretty quick. So that I hit right arrow, and he says, "Hey, I'm making a scope at the bottom. It's scope 0. It's keeping alive the stop. The cursor's on the R for return, and it's going to be there for a while because I'm going to finish setting up start by hitting right arrow a few more times." And he says, "Oh, there's a control pointer in the scope, points to control off start. It points to stop. There's an immediate 0 because I make one automatically in the parser because a lot of places it uses a 0. I just want to have one lying around. I go ahead and flush out the memory for the start node. The parser picks up the memory as well. There's an arg off start. We're still doing things that parser does before it even begins parsing, right? It's an integer. So color coding, yellow for control, dark blue for memory, light blue for integers. He ends up doing the pointers. The gray pointer is a keep alive. Nothing in the scope directly holds onto it, but the parser does. The blue dashed lines are the scope is keeping alive this portion of start. And then I finally come around and I've parsed the return up top and I've parsed the 1. I skipped the return. I'm going to go back and note in here. I'm at the return. I go 1 to the right. I've parsed the return and I've parsed the 1 before I threw the next frame out. Here's your 1. It's uncolored because it has no type info because this is after making the constant 1 and before running people on it. Peopling it just gives you a value for it, so it colors it in. And its type is now the type 1, integer 1. And then I'm putting an add node and I parse it 2. The add's incomplete, only has 1 edge, it has untyped. So it's being hung on to by the parser, not by the scope. There is a nested scope. So scope 1 is the scope of the program, and scope 0 is the scope that you get from the start of the program. It's the whole world scope. So initial values for argument, control of memory.
So I noticed the cursor moves in the source code. Does it moves as what it's represent, or it just
The
moves
motion is
randomly?
me doing dot tweening, which is
Oh, okay.
very, very modestly stupid.
Yeah.
So don't put a lot of meaning into the graph motion. If the cursor moves up top, this is the last place the parser parsed from. And
Mm,
if it jumps between 2 points, that's how far it went before I threw another frame out.
mm, okay.
If the graph moves down in the main portion, it means the dot tweening thought these 2 frames should do something. And he always tweens almost all the edges, and I don't know why. And that's one of the bugs I would like to sort out. They don't mean anything.
Mm,
What happened between frames 10 and 11 was the color 2 filled in, because they're in peoples on a constant 2, and he comes up with the value of 2, oops, value for 2 of the constant 2, for the node 2. No biggie. Then I go ahead and finish patching up my add. Now I'll run a people on the add, and that will type it as a 3 and give me a constant 3. And shortly, I'm going to throw that away and just hang on to the 3. And then I've patched it into the return. And there's control gets passed in return. The return gets typed. It changes color to a yellow box because it's known what it is. Then I throw the frame away, the scope away, and I'm done with the parse. Boom, done.
Interesting. So pretty much more interactivity. So you can track what's really happening.
Yeah, I'm hoping.
Yeah, it's useful.
So here's chapter 10 test out. Somebody did something.
Mm-hmm.
82 frames. And you can skip along them pretty fast here. So I'll go first couple. Here,
Mm-hmm.
6, still at the integer A at the top left corner.
Mm-hmm.
Somewhere in here, I'm going to parse.
The selection where right now we are at the semicolon. They
Yeah,
correspond.
yeah.
So that's you can track where the CF node is right now.
Yeah, and like I said, infinite number of improvements, including stopping when you do a peephole and showing the before and after directly of the peephole with some indication
Mm-hmm.
of this node and his surroundings changed to that node. Um,
Yes.
a lot of stuff. All I'm really doing now is I hooked the peephole code that says if you're coming in here, throw a dot frame out, and you get a dot frame every peephole. And
Mm-hmm.
sometimes two if it's a new node, you get the before and after on a node.
Mm-hmm. So pretty useful. Yes.
It looks cool. Yeah, right. Well, I'm going to do a little bit more. You'll see control flow, and then I'll do a structure, and then we can, debate other
Mm-hmm.
things. So this is mostly for helping people visualize what's going on. So somewhere in the world, I have a double slash. It's an integer divide, and a 3, and he's going to color the 3, and then patch it into the divide, and then decide it's done. And that's sort of what A is supposed to be. So here, the scope 1, the file scope, as opposed to the whole universe scope, decides that A, oops, I can point to it with a mouse, but I can't select it, is an integer divide of arg by 3. And then he's off to whatever next thing is. So he got called after the peephole that installed A, but before he's done something with the 5, the times 5. So he's doing a B here with times 5, which I'm going to run along a little bit. And now I have arg times 5 for B. Go a little bit here. Here is arg times 7 for X, still arg times 5 for B, still A is arg over 3. We'll get Y in there. We're going to get P and G and H, and they're all taking the default zeros. So it kind of builds up. Then there's some random test that no one can do anything with. If arg over 13 equals 0. So there's a 13, there's a divide by 13 here, getting filled in, the gray meaning it's in the middle of an expression, basically the middle of an expression parse. Okay, somewhere he decided he has to have an equals 0 of a divide by 13. And then he settled that down to being I shared the 0 and I shared something else, and it's just what it is. He declares it he peephole finishes peephole the equal, it's a Boolean. The bang is him saying on the true arm or the false arm of the if, I can tell you that the expression arg over 13 equals 0 is 0 or not 0, which is very unhelpful here. So the bang will have no purpose in this particular instance. So somewhere along in here, he gets the guard, the upcast has been typed. Now he throws the if in. The box underneath the if says I haven't filled in the trailing control projections, but they're supposed to be there. Cursor moved past the if. He parsed the predicate of the if. He's going to fill it in. Oh, he types the if. Produces 2 controls. He has no output projections yet. He puts a true projection in. He's going to tie that into a second if. He's decided he's going to flip the sense of the test. So arg over 13 equals 0. He's going to throw the equals 0 away and just invert the test. So you get a second if whose condition will shortly be set to the opposite of the other guy's condition. So it's not invert of, oh, this is a bang, this is a not. I thought it was going to be a guard test. This is a not. I've turned equal equals 0 to a not. Then he's inverting the test, and the second if is bypassing the not. So he's a false instead of a true for the second if. And the first if eventually will just go dead and get dropped, and then it'll delete. Meanwhile, he's going to finish out the if false guy. What did he just do there between these two edges? Sometimes it's hard to tell. Come back here because the peoples just get run willy-nilly on things. Oh, he's about to do something with, no, he hasn't started parsing things. The body's going to get parsed. That is being kept alive. He's cleaned up something again. And he decided to, oh, he finally gets to the other half of the true getting made. This gets typed as true control. And then he threw the other if away. And he's probably getting close to parsing. This is the cast, the paren one. He knows something is a one on one arm. That horrible expression is a one on one arm and zero on the other. But it doesn't matter because there's no repeats there. So he's putting the zero out somewhere. What happened here? He started to add for p of x plus y. So there's an x, there's a y, there's an add. P in the far right is still set to 0. He completes, he knows what the add is. Where did he assign it? He assigned it over here. It flipped around. This is the dot viewer, by the way, flipping left and right. So I have very little control over what he does. But you'll see that G and H just got assigned directly to their respective, they should. Here they are. G and H got assigned respectively to their direct components. It's interesting that he didn't have an edge out here. And he should be at the end, and he's putting the region. This is he's going to do the final merge of P, G, and H. He's got a region. Where's the P, G, and H haven't been sorted yet. I don't know what he did there. Oh, he added another region, another phi. He's going to call them all P because he doesn't have any clue what to call them. The name is just suggestive. One of them is merging these two adds. One of them is merging is incomplete. It's going to be merging. No, it's 1 and 2. It's going to be merging these two things. So in theory, he should be getting, and here's the other guy merging these two things. So he's doing whatever merges happen up here, which if you look carefully, they all collapse. They all fold up. He's doing a reassociative arithmetic inside of an if, and the peoples are going to eventually clean it out here. So I have a region. Here's an if true false. I have three phis. The p's, the names are not suggestive, not helpful. And then he's got an add down here of G plus H. In a minute, he's going to try to push this add up, and you don't get a peephole breakpoint for that to see it. Here he types it. Still around. He's making a new phi, probably because he knows he's going to shove something up through and bring it back down. And the region has dropped down to these two phis because he got rid of a phi in the middle for the push up, push down, collapse. He keeps doing this for H now. Where does he get P minus R? The minus hasn't happened yet. Here's the last plus on G plus H. Looks like it's coming around. And now I have a minus of another edge I haven't done. And the viewer has display issues. Here's this minus. Where's the 1, 2 edge? He knows it's a 0, and he's not going to display the 2 edge because it's dots. Rendering's bad. GHR. Where's R? R, you can't tell because it's scrolled off. It's equal to the plus there still. So he hasn't folded it yet. I was hoping he had it folded. Oh, he did. Return is now known to be 0. Somewhere at the end, he drops the scopes, and then that's it. You get this program here, which then collapses because, I'll go back one, because the region merges nothing. There are no phis on the region, therefore it merges nothing, therefore it's pointless. And you get that.
Cool. Pretty
Yeah,
cool.
kind of cool, kind of
Yeah.
crazy, kind of cool. If you do it step by step and carefully know what's going on, you can kind of see what's
Mhm.
supposed to happen. On the other hand, they get complicated quick and then they're like less helpful.
Yeah.
We'll
Mm.
do one
Well,
more and then I'll be done. This one is just showing a little bit of memory things, so you can see the color changes in memory and some of the stuff happening here. So struct vector 2D. Vector 2D is a rewritable new vector. I assign a 1, I assign y to 2 or 3, and return the vector. So the parser starts putting his own personal state in, and he has arg and he's ready to go. So when he parses a struct, he makes a private scope for the struct. So 0 is the whole universe. Scope number 1 is the file scope. Scope 2 is the scope of the vector struct vector 2D. So he's done through the vector 2D parse. He's up to parsing the first term in there, and this is a full block parse so that you can have initializers. So basically, I'm making a prototype or a constructor, and he's going to pre-fill in all the things that you put in static initializers for, and that's the scope, is all your static initializers. There are none in this program, so it's very boring in that sense, but you get a scope for it. So he's going to walk along, he's going to have a 0 here in a minute, he's going to make you, he's got, here you go. He declares X is in this scope. So he doesn't yet have a struct vector 2D object floating around. He only has a block that has X is 0. And then he's going to screw around and come up with Y is 0. And then he decides he makes this light green. This is me declaring a struct type. And I'm going to fill in X and Y fields and type it in a second. So this is a struct. Oops, I can't highlight it, but yeah, I can do that. Yeah, there's some bounding box funny issues here. The vector 2D type is the type of a struct. It has two fields. They're both typed as a 0 out of constructor. So they're integer 0. You can reassign them so they don't have to be 0 all the time, but the type is known to be a 0, and the bang means it's rewritable. So you have a mutable field X, mutable field Y, both set to 0. And that's the type of that thing. And I pop that scope because I'm done declaring the struct vector 2D, and that is the green box is the type vector 2D. The arrow, the 0 coming out of it is because that's the field initializers for the prototype, if you will. The 16 that's sitting on the right, that's the size I'm about to use. That's I'm about to do for the new vector. Make a new vector, I need to do an allocation. So one is a descriptive struct. It hangs around because it has executable code. This is how you run stuff. But the next piece is I'm going to do a square box. That's a new allocation. 16 is the size of the allocation in bytes. And I'm going to fill in a bunch of other things. So the control makes me pin where I allocate. There's a memory edge that's going to be for the aliases which are coming up. The zeros are going to be pulled in there for initializers that get rewritten over time. Here's the type. Has a control. Oops. Oh, look at that. There's a zoom in there. It has a pointer to a vector 2D and a memory state 2 and 3, both initialized to 0. And I'm still filling in vector 2D here, so I'm not sure what piece that did. Here's a memory 2 as an output projection. And it's set to known to be alias 2 is only filled with zeros because in this program, there's exactly one new vector and it's exactly only initialized to 0. So exactly only alias 2 only has a 0. That field X is only set to 0 in memory. That would be usually bottom of some kind if you had more structs floating around. So I make a 2, I make a 3. Those are for X and Y. The aliases for X and Y. The parser picks them up in scope. So scope 0 lazily produces memory aliasing edges. Otherwise, they all would default point to memory of top or bottom, which is says all possible states of all memories. But now I know something special. 2 is not an all memory. It's only field X, and Y is only field Y. Whatever, 3 is only field Y. What do we get here? The vector 2D finishes out. He has a third output, which is a pointer. So he produces two states of memory, takes in a state of memory, produces a state of memory, and produces a pointer. And he mutates the alias 2 and alias 3, jamming a 0 down. If I had multiple vector 2Ds created and they were jamming different things down, alias 2 would quickly become bottom integer. Like I don't know any X field, I don't know what it would normally otherwise be. So I'm building up for the v.x equals 1. So I have a v state now, don't I? file scope, and it points to some vector 2D. He has a star vector 2D. And then he hadn't pulled out his one yet. He makes this point to the projection on the new. There's my one on the right. And where's my store happening yet? I don't know which piece that one. Here's the store. Dot x equals of a one. See, 0 is control. 1 will be the alias of alias 2. 2 is the pointer. 3 is the offset into the struct. So I have an offset math. So this is base of vector 2D plus 0. X is at offset 0 in the struct. And the value is 1. I'm storing a 1 into. And then I type it and I say, oh, you produce alias 2 memory. Alias 2 memory is now bool at this point because it either has a 0 or a 1. And I assign that into the main state of parser's alias 2. And then I'm probably going to pick up an if arg test. Here's the if. And it's typed as 2 controls. He picks up a true. It's typed. He doesn't want to play the inversion game because the test is too simple. So he picks up a false. It's typed. He picks up an 8, which is going to be the offset to y. And he's got 2 scope piles at the bottom. One's for the true side, one's for the false side. And I don't know which one he's working first. Looks like he might be doing the one on the right first. Hard to say. Yeah, picks up a v on the right. V dot y is equal to 2. He has the 2. He has the v. What did you just pick up there? Here is the dot y for the right-hand side. Offset 8, alias 3, value 2. Let me see if I can assign what happened. Something changed between here and there. Oh, he types y. Y is now an integer range. The memory for y is an integer range 0 to 2. It looks like he flipped sides here. I missed what he did here. He moved it over. Oh, he picked the alias state for the memory and then he flipped sides on me. So alias, the parser knows that the alias memory for alias 3 is 0 to 2 and points to this dot y equals. What are we picking up here? I am picking up the other side of the if test. If arg is true, we did. If arg is false, well, that means it's going to be 0. Somewhere in here, I'm going to know it says 0. And I don't use arg on that side, so that didn't help me any. Here's an offset 8 again. It folds up in the other offset 8. There's where my 3? I bet you there's a 3. There's a 3. He types a 3. He does a dot y equals of offset 8 and 3 and everything else. He plugs it into the memory state. Oh, he didn't plug the memory state yet, and then he did. Okay, so I'm now doing the region here. So here I have a region of an if true false. I have a phi that merges alias 3. Notice that no other aliases got merged here. Nothing else got merged here. It's just the alias state 3 getting merged. Not v pointers, not the x fields, not anything else. Fine.
Hmm.
Let me go back and forth so I can spot what he did here. No, I can't tell what he did. I need the noise of all the edges moving hides the action too much. So here I'm going to do a merge of arg. So what happened here is that I knew that arg was 0 in the else clause and arg in the true clause. And so I merge a 0 and a true, or merge a 0 and an arg, except that I also know that the arg is unchanged because it's a cast. So eventually I make a phi for the arg, and then I'll decide it's useless and throw it away. It would have been useful if I was using arg in the else clause because you would know the arg was 0 and you could just substitute it in for 0. But parser makes it and then throws it away because no one's using it. What am I doing here? I should be winding down and getting rid of things. I'm probably building a return, building a V for the return of oh, he hasn't plugged in the V yet. But the return takes the memory state of memory 3 and takes the memory state from memory 2, and he takes control. come back here, you. And then he plugs in, he should plug in. Oh, he typed this guy. Oh, he must have plugged in and not seeing it. One. Okay, the alien, the blue and the green line lined up here, and he points to vector 2D. So the return is doing that. I get rid of the entire control, the scope. And then let me see if I can make this. And then this is your program. So he returns the merge of the memories for the two Y stores. And there's a peep that could happen that you could do one Y store after you merge 2 and 3, and so on and so forth. So, oh, he get rid of as part of the thing, he gets rid of the structure definition. So here's your constructor, vector 2D. He takes, oh, that's some of the things that happened here. There's no X clause. Let me go find when X went away. He folds X in. Right here, I have X as a store pointing at a new allocation. That's the green pointer edge of the 2. The memory comes from the same allocation. Then he has an offset and a thing he's storing. So you're just storing into a new allocation. So he does a constant fold. He does a peephole that says a store into a brand new allocation can just replace the allocation's initial store. So the allocation has an initial store up here of alias 2 is a 0 and alias 3 is a 0. So X was set to 0. Here's the 0 input. We step one to the right. And now I have a 1 coming in here and a 0. And that's because X memory is set to 1 and I don't have an X store anymore. I got rid of it. But basically, the new allocation starts by initializing memory all to 0, and it was followed immediately by a store of a 1 into the same object. So he just says the new allocation stores a 1 in and get rid of the store out. It doesn't help things per se unless you have a forced 0 initializer that you can get rid of some of the 0 stores. Kind of depends on what your allocation strategy is. All right. Well, Arthur showed up late, but you missed it. I'll run the eye candy backwards for Arthur's sake, and then
What was that?
This is a demonstration of simple doing peephole optimizations and parsing. Go all the way back down to the beginning. Program upper left corner. Graphics are a little raw, and they're also done with .graphviz, which gives me some great layouts and some difficult to manage or control exact behaviors. And the parser starts in the upper left corner of that program and begins building parser state. I'm going to go really quick through here because everyone else just saw this. So the parser has a scope 0 as the whole universe. Scope number 1 is the file scope. Scope number 2 is the scope for the struct definition and parsing. I'm parsing struct definition. The 0 came for free because the parser makes a 0 because so many people use a 0. I just have one lying around. And then there's a start of the program, and the parser's current scope points to the start of the program. That's sort of what happened there. Now I'm going to finish parsing out struct 2D. I'm going to find an X and a Y. I'm going to go back a little bit here. So scope 2 has an X and a Y both mapped to 0. The green is a structure definition, a type definition, except it's like a constructor in that it has initializers for all the things, all your static initializers for all the things that are in the struct. So X and Y are known to be typed as type 0. And they are not final, so they are mutable type 0. And that didn't allocate any memory. That just stored a description and the code necessary to run the initializers. If I had code up in there like x equals pi or whatever, that code would be represented here. Moving along, I'm going to do an allocation. I'm going to fill it in a little bit. Here, I'll stop here. The square box is an actual allocation. The size of it is 16. It's two 8-byte integers, so that's the size 16 struct. The 0 is being pulled into the vector new because he's setting x and y to 0. There's a memory state being pulled in because he's going to modify memory. He's going to produce a dark blue memory out. Alias is 2 and 3. Alias 2 says that all x fields everywhere in existence today are all 0. There's exactly 1, and it's 0 because I'm setting it to 0. And then 3 is going to get typed in a second. So I now know it's a memory type and it has the same contents of memory as 0. And the parser picks them up down below. And I'm basically done with an allocation of a vector 2D object. And then I'm going to run over here and start doing things with it. So the graph moves left and right according to how GraphViz does layout, and I don't have a ton of control over that. But I've lost scope 2. I'm back to only file scope, and this file scope declares a V, and the V is a pointer to a vector 2D, and then there's the start of the universe, which is the memory state. So I'm going to whip along till I find a dot X getting in here. Somewhere in here, I've made a dot X equals. It's typed memory's typed as a bool because the X is a store of a 1, and it had been a 0. So contents of alias 2 are 0 or 1, which is bool. And I'm about to do the if. So I've started the if test here. And the if test moves along and eventually becomes an if true false. And he's building up an 8 here because that's the offset for v dot y. And he has two scopes at the bottom, one for the true side, one for the false side. Let me go ahead and run along a little bit here. Here's y equals, takes alias 3 instead of alias 2, offset 8, storing a 2. Pointer is the green line to the vector 2D.
Are these scopes just side structures for the parser, or
Yeah,
they are part of the IR?
they're side structures for the parser.
Okay.
Hey, Aaron. So as I get toward the end of the parse, I'll throw them away, and you'll see what's left over. And they contain most of the edges in the graph right now, and that's typically the case. They contain, for small programs, they contain nearly everything. For the larger programs, you do get a lot of IR because the program is large. Okay, so there's dot y equals 2. He's going to type it. It's a range. The memory state for y is a range from 0 to 2 because I store 2 in, and it had been a 0. And eventually he plugs it into, we switch sides, and here's, GraphViz going nuts on me. And now alias 3 is 0 to 2 for the true side of things, and I'm probably not yet lined up to the false side. I'm lining up to the false side. I'm going to put in a cast where arg is cast to a 0 on the false side. No one cares that it's cast to 0. No one uses arg, so that doesn't help me, but Parser knows, he just does it. He's going to line himself up to get a offset 8 again. Somewhere I'm going to get a 3. Here's your 3. The cursor's up here. He's parsed a 3. He's going to jam in. He types the 3. Somewhere he's going to jam it in. Here's a dot y equals. Same state of memory from the beginning of the world. He stores a 3 in. He's going to type it 0 to 3 instead of 0 to 2. The type goes into memory, but now he's folded the two sides. And so what happens here is that the GraphViz instances come out of the parser. The core guts of the parser, I said, if you're doing a peephole and you're doing this crazy thing, go ahead and dump a graph dot out. So I get a lot of these GraphViz dot files. So you get 62, but they're not necessarily where you want them. And sometimes you skip places, and sometimes you get duplicates or close in time things that don't have any interesting state. So
Are
here's the
these
merge. It just happened. If I go back one notch, I have two scopes, left and a right, two states of y. Nothing else is different. The alias 2 for x is this blue dashed line. The alias 2 for this is also the same two dashed lines. So alias 2 is unchanged with the two sides of true and false. Alias 3 is changed, arg is unchanged, control will be the region, and so on. So when I merge them, you get a one phi there for alias 3.
are these visualizations done just by GraphViz alone?
Yeah.
Hmm.
With D3 tweening. So it's all in simple branch chapter 18, the chapter 18 directory, and there's a JS viewer, and you can just say Java space JS viewer, and you write a program, never left, and click outside the box, and it'll start. And then you can go look it through. I just walk the graph and I do .viz on the graph as a graph tender. So I can step you through how it works. It's very straightforward. And there's plenty of places where I could use improvements to graph and force better layouts and get rid of the double pumping of the edges. That's like a stupid thing. It distracts where real changes show up. Like I would love to have the difference between the graph edges be highlighted at least one frame and not the double pumping. I'd better have a, God ray glow around what changed. Something.
Also, it would be interesting if you click on the source, like when you're tracking.
Oh,
If you
and I
click,
jump to the nearest frame.
yes,
Absolutely. Absolutely.
Yeah.
That's a better plan than my plan. I was planning on putting a box you can pick a frame number, but
Mm.
I like clicking on the
Yeah.
source and then you go
Yeah.
backwards and forwards a few frames and you'll find exactly what you're looking for. That's a better
Yes.
idea.
Yeah.
Okay. I'll finish out for Aaron and Arthur's sake because we didn't finish here, but it's close. At this point, I'm ending up the if test. I'm gonna throw down a couple other things here. The arg was had a cast from true to false, so I knew that arg was false in the else branch. So the parser knows that arg has two pieces to it. It has untouched and it must be cast to a zero. He's going to get rid of the fee on that in a second. He types it and he says, it's a junk fee. So you end up closer to this here. I got to be getting close. I'm going to drop the last frame in a minute here. What did he do from here to here? Or I can't see, and it may have been nothing. Like I said, I get some junk frames. Um, Here I'm building the return. And the return has control from the region, has a one over here. It's hard to see. I think that's for the returns, pointing to vector 2D. He has a two, which is pointing to dot x equals, and a three, which is pointing to the phi on y. So he's taking up all the states of memory. Alias two from here, alias three from here. So return takes all the states of memory so that your memory is alive on exit. Otherwise, your memory would die when the scope ends, and he would throw away all the stores because they're not needed for the answer. Because the answer is going to be return V, not return the contents of the Y, which is the only thing that changed between things here. So he types this guy. The return is typed as a tuple of control and appointed to a vector 2D with integer fields X and Y that are mutable. Fine. Throw the scope away. Graph cleans up a lot. And this next one is there's going to be a peephole post parsing. So I'm done parsing. That's why the last scope went away. Post parsing, this X is adjacent to a new allocation. And the new allocation stores a 0 into X and a 0 into Y. This stores a 1 into X. Since it's pointer to the new and the memory comes from the new, he can just have the new allocation set X to 1 directly. So he'll fold that in. So the X field goes away. And instead the vector 2D takes a 1. Now it's slot 4. That's filling in the X field. You see the pound 2 colon 1. I'm hovering my cursor over. That's the memory state for alias 2 is known to be a 1. The projection slices it out as a 1 and so on and so forth. So that's in the program. Return of 3 of merge of two stores of either Y of 2 or Y of 3. And a region does whatever it does and so on and so forth. So I can put other programs in here. We can type them live if you have a particular thing you want to see, like expression parsing for precedence or while loops or whatever.
Let's see
Yeah,
a while loop. No?
Yeah. Okay. Um, what is the easiest while loop I have lying around? Somebody else said while loop too. That's an ugly one. I have them all. That's not terrible. That's terrible. Oh, I see what I mean. Emacs thinks that my dot dumps in
I
my.
assume you can't show tail recursion because you don't have functions.
I don't have functions. That's this chapter's work, but I don't have function right now. I have a lot of evil things from the fuzzer. Here is a bad guy. I don't want to do this thing. It's complicated as hell. I'll do it. Here goes. Let me do a simple one first, and then I'll give it up and go do a complicated one here. Int sum equals 0 for int I equals 0, I less than arg, I plus plus, sum plus equals I. Return sum. That's like about the minimalist obvious one you can do. Come back here. Somebody said something about chat. Let me see if I can find a chat menu says something here. Oh, gotta go early. Fine. Yeah. Okay. So the first 5 or 6 cases are the parser setting himself up to parse, and he's going to parse sum equals 0. So here is, so that went quick. So let's go back one. So here is I'm at the end of sum equals 0. So I do the equals 0. The 0 is there. Now that I'm at the end, I'm going to declare sum at the file scope, but I don't do another peephole till I'm already into the for loop. So here's sum in the file scope, points to. I'm now in the for loop. I get a new scope because int I is in file scope only, disappears. So this number 2 here is file scope. I'm sorry, for loop scope. So here is for loop scope. You can see where graph is shared the zeros, so I is pointing to 0. Fine. And then there's a loop header put in. And in a second, I'm going to put an if test for if I less than arg. So here I have two scopes. One's going to be the loop exit, and one's going to be the body. And I've picked up. Oh, he hasn't done aliasing correctly here. Why is this guy some? This is an obnoxious thing. Oh, it's a
Is
bottom, and I have a bad graphics display. Oh, I get it. Okay.
is there a reason why the loop body can't be inside of the exit?
When you say the loop body inside, you mean in
The scopes, I mean the lexical scopes.
the body? No, no, the exit is the exit. You're out of the loop. By definition, if you're at the exit, you're not in the loop.
You're right, but could you say that the body, like, can the body of the loop be nested inside of the
Of
of the
another
exit,
loop.
or if the exit is just the continuation of the outside scope?
The exit is the continuation at the outside scope. So the exit is as if you took in the body of the loop, you said break. All the breaks that you do in a body of any loop go to the same loop exit point, and it's the same point you get when you fall off the bottom when you fail the initial test. And
Right,
those are
yeah.
going to be one of the two scopes at the bottom of the screen. And the other one will be the body itself. So there is an exit spot which will gather up all the exits from the loop. There's a head
Yeah.
loop which gathers up all the continues.
I think I may have just confused myself because it makes sense to me now.
Okay, fine. And so I'm busy trying to build out a loop, and I'm sort of in the loop header construction business at the moment. And I know in the loop header construction that I have an I value, and because I don't know what comes around the back edge, in fact, I will be mutated, um, I need a phi function that's sort of eager because I'm going to find it in a second. And then I have an arg, which also is there because I don't know yet the unparsed body may change arg. It doesn't, but the parser doesn't know that yet. So he throws a loop phi header down just in case it does. So he's still discovering things. These phis are all lazily generated at first touch inside the loop body. That's not part of the display of the graphics here. You can't see the lazy mechanism at work. So the first time I find a touch of I less than arg, the I equals 0, that's outside the loop. I for I less than arg here, that is inside the loop. So the first time I see something inside the loop, you get the phi for it shows up, and then the mappings on the scope make it happen.
So the two things that go into the fee are the initialization and a unknown forward reference. So it's not going to get removed because it still has an unknown forward reference, even though
Yes.
it's done.
So if you look at these, they have a 0 edge out. That's the control. They have a 1 edge out for the initializer. They don't have a 2. And the 2 is the back edge. So these phis will not collapse until they get a 2 edge. That won't happen until the for loop ends.
Thanks, that helps.
Yeah. Okay. So slap the control down on something here. He's typing these guys. They're all known to be integers. Um, he's typing the bool test for the less than. Here comes the if. And it's typed, and there's a true, and it's typed, and there's a false, and it's typed. And then it's starting getting to, let's see, what happened here? What did this do? Oh, he puts the bang in. This is the I less than arg is true or false in the body here. He knows it. And again, I'm not using that expression in the body, so it's not going to help. That'll show up if I do null checks. I can do a null check version of things, and you can see the bang cleaning out the null checks. Okay, now I end up with 3 because I have to have a continue. So something points at the loop head, all the continues in the back edge come to this one on the upper right. Something's going to be the loop exit. I suspect it's this one. Oh no, this one here, possibly? No, I think this is the body at the bottom. I think this is the exit. You always end up with 3 on a loop. There's the continue, there's the exit, there's the body as it progresses through the parse. So he's going to cast I less than arg to, 0 on some exit test and some entry test. He's still screwing around here. I can't tell you because he shuffles. I don't like the shuffle. He's coming up with some. Some has appeared in the body, and the parser has just parsed sum, and he's about to do, plus equals in a minute. So sum is given an integer value. It comes in with an int. It's going to go out with an int, but I don't know yet. Here's the plus of sum and I. That's given to, it's typed. What do we get here? I'm doing I plus plus. I'm closing on the edge here. One of these will have a +1. Here's the +1. Here is plus of phi of I and 1. And he still hasn't patched it in yet. And this here is a bad graphics. That should be known to be an integer. So it's typed, the graphics are wrong. He closed the thing on the loop. He got rid of probably the body, and he's doing a back edge, and he's doing a continue. One of these is probably the continue. One of them is going to be the exit. This is probably the exit here. He drops again down to just taking the exit. So let's take a look here for a second. So here's a loop. Sum I are the two phis involved. They're both initialized. The I is double-headed arrow here with a plus and a 1. So I is I plus 1 in a tight loop in the body of the loop, and that is exactly correct. Sum double-headed arrow with a plus of I. And so that's sum equals sum plus I in a tight loop. I less than arg right here. Here's the exit. This value is in the exit. The true side goes back to the loop, and the loop goes to the if to the true. And then the false goes to the return, and the return says I'm returning 0. And there's a bang being held onto as a guard that says I knew something about I, or the negated version of that, which I'll drop probably in a second here as I come down to the end, and then I get rid of things. Yeah, there you go. There is a straight up sum.
What more would be required to optimize this down to something as simple as sum is equal to arg?
Sum is not equal to arg.
Um,
Sum is equal to the closed form solution of arg times arg minus 1 over 2.
Oh, I see. Oh, I misread. Well, could you bring it down to something closed form then instead of the loop?
Yeah.
LLVM certainly does.
Yes, exactly. So
Which very much surprised me the first time I saw it come out.
Various micro benchmarks were hard pressed, and I was in competition with both C programmers and other JVM IBMs, JVM instances. So we worked hard and did a valid legal transformation of certain kinds of closed form solutions. This is one of them. And he will substitute, C2 will substitute it using exactly the pattern match you get by looking at this program. I see that I have a loop, and it has a phi and a phi, and this is a plus of that, and this is a plus of a 1, and he does an induction variable analysis first, and so this becomes an induction variable, and so I have a sum plus an induction variable. Oh, I close from that sucker. Bam. So yes, you can do this. Now, is it useful outside micro benchmarks? No.
The cool part about how LLVM does it, it doesn't do it through pattern matching. It has this like simple reasoning engine, scalar evolution, which as a side effect can also come up with closed form answers for these kind of values.
Right. I went down the path of how far do I want to go doing closed form solutions for micro benchmarks, and the answer was like, I did a few and I walked away.
I wouldn't say it's for micro benchmarks, at least in C++. When you access a struct, maybe you have a struct of an array, and you access this in a loop, and you walk through an array in that struct, you want to compute the coordinates of the field so you know the offsets. And the reasoning about those offsets is very useful for things like vectorization or memory layout analysis.
Okay.
So it's a pretty fundamental enabler for other optimizations.
So C2 does the basics of that directly, yes. But Java does not allow convenient 2D arrays. I even know how to fix that fucking thing. But as it stands, Java's 2D arrays are not guaranteed to give you the nice layout. So C2 did not go down the path you're talking about. I do the one-dimensional version of that directly. It's induction variables. I do all the correct induction variable analysis. And then like do the 2D form layout for things? No, because it's Java. You can't do it well. So I went on to doing other things. Like the next loop I was going to show is a simple loop, except he cleans out an iterator, which doesn't really matter typically to the C Fortran kind of codes, but matters a whole lot in Java. Well, that would not be doing the right thing here. Come back. How about now, brown cow? Oh, here we go. So this is, I make an iterator, and it says, make a new iterator, set its length, the end of the iterator. I don't have function calls, so I can't have any syntactic sugar for this or anything. But then I have this sum, and while the iterator's x is less than length, add the iterator value and iterator plus 1. So this is straight up same loop we had before, except with an iterator for the induction variable for I. So you get confused by having a memory state to go track through the iterations through. So I'm just going to run along here and stop for a second here. So I have a struct iter, it's declared. I have a new allocation of iter, has a pointer to an iter object it produces and an updated state of memory. Go on, run around for a while here. Somewhere in the world, I'm making a loop. He's going to feed the pointer in case you change the I itself. And he's set length to arg as a store of length equals arg, and life goes on. So I'm gonna whip, come back here. There, this disappeared out from under me. So we'll go a little ways here. Somewhere, let me stop where I can tell where the cursor is. We'll take a look. Yeah, so somewhere in the, come back here. Wow. Okay, somewhere in the universe, he's declared, I have an if in the middle of the loop. X is less than Y, so it's a load. So this is dot X is a load. Dot length is a load. They take memory states, the green edges off the pointer. I'm sorry, they take pointers for the green. They take memory state for the X off of alias 2 or alias 3. I don't know what the back edge will bring around for alias 2 and alias 3. Here's a length store. That's the initial value for alias 3. So kind of an uglier mess than what we had before because we have a layer of indirection. And then come back. Let me just run along a bit here. Yeah, there's the 3 state. No, so this is where I need your jump ahead because I don't really want to go through all these gruesome in-between states. So here's sum equals sum plus I dot X is mid-progress here. Here's the plus. Here's a dot X not typed with the plus. It folds up to this dot X. So I CSE this I dot X with the prior I dot X. I still have a plus. The plus picks up this I dot X. So this I dot X now got shared as part of that. I've added a sum here. I'm about to add sum to it and produce a new value for sum for the back edge. I'll run along a little bit here. We'll find a store for things. So we're doing I dot X plus 1. So here's length and X still. There's a less than. There's a plus for a sum variable. Where do I get my second dot X? I probably did it and folded it and missed it here. I'm typing this. I already folded it in. I was hoping I would see it. Looks like I folded it in directly. I never got a chance to see two I dot X's. Nope. He immediately made and folded the second I dot X, and he puts the 1 in, and he types things, and he gets a 1, and then he fills it in, types it. What else we got here? Here's the store. Store gets typed, goes to the memory state. Store gets typed. Okay, so the fee didn't know what came around the back edge. It's a store of an X. X didn't know what it came from the fee, so it's also a bot. So I have lost in this tight loop of the memory that X only contains integers because this is a bottom-up, peephole, pessimistically always correct graph generation. So I can pattern match to lift this, but I can't type flow to lift it. So what are we doing here? We got to come to the end and get rid of some of these scopes. I get rid of one of my scopes. I'm getting near the end. Here's the other scope. I have this mess. We'll recenter, grow, come back. Here's a return. Here's the double edges for the memory being modified. Here's a length. As I know that I'm done modifying things, I can start doing other peepholes, but I don't have any markers for them here. Here is getting rid of the last scope and going to the iter peeps. So the parser doesn't go backwards on its peeps, but iter peeps hits the work list. And a bunch of these things are on the work list because I have 8 more frames to go. So something disappeared from here to here. Length equals moved some. I had another one here. No, can't tell what happened. Oh, I got rid of the length here. This dot length is a load of a store. The store of length here comes from above. I've lost the fee for length for memory. So I'm just going to get length from the value that I stored in. So I still store length for exit because the iterator's, available, but I do not need length as a field. I'm only taking the value for the if test less than from twisty, sneaky, curvy line to arg, and dot x is less than whatever. So I got rid of length out of the loop, the load of length out of the loop. Here's another go. He's getting a dot x. He's going to push this around a load here. And let me get rid of dot x store in the loop, I'll bet you. What do we got here? Sum takes from a plus. So sum has lifted out of the dot ix. Sum knows that he is sum of the field, the x field, not the dot x loaded from memory. Boy, it's hard to see what they're cleaning up here, but they're cleaning up. Now this sum is a plus of x, which is a plus of the 1 here. So this is the x field being plus 1 as lifted into registers. Sum is plus of x lifted into registers. The less than test here is from arg and x lifted into registers. And I have a dot length field getting stored and a phi of a dot x field because I've made an iterator and I wanted to initialize it. And I didn't do the final clean out of those, although I could have. In this case, because iter is not alive on exit, it's not passed out, I would claim I don't need to have .x stores and .length stores. But I make an iterator object, I actually allocate it. Let's look at the consumers of the iterator object here. So here's iter is made. Here he has a memory use, and he has another memory use, and he has a green pointer, and has a green pointer. This goes to a store, this goes to this guy, which loops. Both of these are only then used by return. So the entire iter is only live because the return expects memory to have been updated. But if no one asks for a pointer to the V object, I claim you don't care what that memory state is on the program exit. And then as a people, I would say the return just nukes the memory edge, and then those would delete, and the new would delete. And you would be back to the original program. This is the kind of shit that Hotspot does really well that was way more important than 2D arrays.
That's called scalarization in LLVM. So essentially converting memory accesses to temporary scalars, which are just compiler temporaries that you keep in the register.
Yeah.
Just out of curiosity, because I missed that, what was the moment when you introduced the temporary scalars in your case? Was it when you were analyzing the phi nodes?
You mean here on this display, like you have an estimated frame number?
Because it was a lot of steps and I missed that point.
I zipped through a lot because they're tedious for time. So you have an estimated frame number. We have like 90 frames. I don't know which one.
So when was the point when you introduced the compiler temporaries or the scalars?
Okay, so the compiler temporaries are introduced as a peephole. Some random peephole does it. There's no phase. It just happens when the compiler does a thing. The common way they show up because there's a loop. If you're not in a loop, they happen instantly as you reference them moment by moment. With a loop, the fees prevent me from understanding that I have a situation involving a compiler temporary until I clean the loop out. Here is an example. I have a fee, so I've closed the loop somewhere around frame 81. Somewhere I've closed the loop. This fee here is the fee for alias 3. You see it has a self-reference. That means it's a dead junk fee. It does nothing. It merges the prior memory and itself, which is the same as no merge at all. So that and then right behind it is this load. So when I get rid of this fee, I'll have a dot load of a dot store. And I just do a load store, I lift it by just saying, oh, the load must load from the store. So let's go forward a notch, see if I can see this fee go away. And that was not helpful. Wow. Okay, the display was bizarre. Come back. Here I am in this display. 80, there's this guy. Switch. Okay, 81, I got rid of it. So I just did a peephole, said fee of self is useless, throw away. Now I have dot length of a load of length for the store of a length. The memory state is the same. The pointer state is not, so I can't load yet until I get rid of this fee. But this fee is also a self cycle. It just says that no one changed the pointer to I. If in the body of the loop I said I is a new iterator that I've never seen before, then I would have to honor those semantics, kind of ugly. So in this case here, I don't know what the dot view's doing here. He got rid of the dead fee for changing the alias, the iter I. So I is unchanged in the body of the loop, and he knows it as a peephole. Now I have a dot load of a dot store, and they both have the same pointer, and he has the memory straight from this guy. So at this point, I could just take the value that gets stored here. It is a legal peephole. It is not known. It does not require any special pass. It's just a localized job. Looking at these two nodes alone and nothing else, I can peephole.
Okay, so it basically falls out of two kinds of peepholes: the cleanup of the trivially dead peepholes and the store to load forwarding peepholes, basically.
Right.
Right. Okay.
It didn't happen on that peephole. Something else happened. That's not very helpful. It happened here between 84 and 85. This here and the less than points to the length, but he should be pointing to the value, which is arg. So go step forward, and I have a less than. He does the long snake to arg. And the load disappeared. Yep. So that was my last week of hacking on Simple. And like I said, it has a bunch of things I would love to do to improve the quality of the display. I like your suggestion of finding the nearest frame of wherever you click up in here. I think that's a great idea.
Yeah. So, but we may want a button to control that. So if you're clicking here to not constantly jump here and
well, there's a bunch of somehow the where the graph viz document shows up in the frame gets extra things added left or right that I'm not clear why. And if you click outside of the buttons, there's a free zoom, which I didn't ask for, but I didn't turn off. Which means if this box moves down at the bottom of the screen and I click at that place, then I miss the box and I zoom now. And then suddenly, instead of going forwards, I'm zooming. It's like, no, stop.
Yeah, with the jump, we maybe have a checkbox in order to enable or block jumping from the source to the nearest frame.
No, I think as soon as you click over in here, your intention is clear. That you intend
yes,
to.
But you may not always want that. So if you are in a explore behavior, then you always want that. But if you edit the source,
if you're editing the source, as soon as you edit the source, all the frames are toast.
Yeah.
So I claim as soon as you edit the source, I should mode flip on you immediately, and I'm waiting for you to click outside the box to declare done editing.
Okay.
And then as soon as you're done editing, I start loading new frames. I compile and start loading new frames. Yeah, I kind of want someone to highlight what actually changed. I want the changes to be centered, force the graph. It's going to move anyhow, center around what's changing.
Another idea would be to select the source from a while and to render only that selected source, not the whole graph.
Well, I don't have any way to not parse the whole graph to do a selected region. So what instead I can do is tell you the range of frames that you come from. Like if you click in a region up here, there is a range of frames.
Yes.
So I could somewhere say you've selected this range of frames, and I'll put you at the
Mhm.
first one. But now you can step forwards and backwards to your heart's
Yeah,
delight,
yeah.
independent of other things.
That would work also.
And I can't really do. Oh, I can do range of frames. Yeah. What happens that I don't have at the moment is I have the cursor offset, the parser's cursor offset, and a frame to go with it. So yeah, I could sort you out.
Hmm. Cool.
Yep. I'm trying to think if there's any other things that would be interesting to show here. I was going to do an if test to show the cast, because that's kind of like how do I force the correct behavior of if not, that's got to be chapter 10, right? No, what's chapter 11? What's a giant guy. Me finding things here. Chapter 12 was something else. Floats. One of these did references with null checks. Looks a lot like here, this guy. Where would I say a reasonable null check that won't go out of control on you? This is not necessarily a great one because I didn't pick it for small, but I think it'll show you null checks coming along. I have a tighter one for the null check case. That one just does like an if. I have these fancified things. See what happens here. It's gonna be too big. Okay, where do you go? Yes, thank you. Why? No one knows. Okay, so parser, yeah, parser gonna pull out a struct linked list of ints, takes a linked list nullable for next and an int I, and I make a head to null at some point. So we're going to fill in LLI. It has a known null. It starts with null for the next field and 0 for the int I. And I'm building up a loop, and I'm going to run a test here. So I kind of want to whip through. So yeah, he moved the thing on me. Here's a new constructor. It's just going to be unreadable, so no point to it. Get past the loop. Where am I doing? Right at the end of the loop. Getting close. Okay, let's see if this is readable. If in a loop, there's a constructor in the loop, he sets the next and I fields. I would love for them to collapse here. These two should collapse. That would be nice. They might yet. And then there's arg is, -1 to go count down to 0. And I'm storing at offset 0 and 8. And there's still a constructor definition. Here's the fee for the loop head, which initializes the null, but then it becomes not null all the time as you get stores into you. So somewhere here I have to know that everything's not null at the time I do these stores, or I should blow. But the blowing test happens later, so he hasn't declared not null yet, I don't believe. Here, these guys are known okay because they're doing straight off the new allocation. So I say new LLI, that's X. These two tests, X.next and X.I are known not to be null, and I set head equals to X. So yeah, there's no null checks going on here yet. All right, now doing if head is coming up here. And he's going to have another if. Very ugly. So you put the predicate on the bang of the head from the loop exit. And the loop exit thinks it might be null, so he's got a legit test. Oh, this one might not have any null check elimination going on. because head might be null. Yeah, this one doesn't do anything, and the parser knows that parser. The parser knows it too. So here's head. I could show you here. Where do I get my? He hasn't got there yet. Oh, because he does a return 0. Where am I doing the else clause? I'm going to find where he's going to cast you to not null. There is a not test of head. The question mark at the end of head says, I might be null, and the bang says, if null, exit else, do whatever you're going to do. And then, where is the cast? Hasn't happened yet. I want to say, no, he still doesn't know yet about head. He's got to do the return 0. I bet you he's going to parse the return 0. Not very helpful there, guy. I'm still doing return 0. Here's the return 0. And on the return arm, head is known to be null. If not head, return null. It's known to be null on the return arm. That's one of the interesting things. Let's go the other direction. Here's a void star cast. This is a cast that says you are not null. And I don't know what you are. The node itself is just a cast not null. So it's a void star cast. But the type of the node is a pointer to an LLI with no question mark at the end. So it's a not null pointer to a linked list. So he knows head is not null at this point. Somewhere in here, we're still on the other side of things. Here I am. Now I'm parsing the else clause, and he's going to say head is not null. Head is not null. That's the only thing that's going to show there. So you can do head.next without throwing a null pointer exception or without putting a test in. The user had to write the test or the compiler would have rejected him. So let's just run along here, see if there's anything interesting at the end. Here's a read only. What's that? Well, that said, I wasn't allowed to modify something. One of these things is not modifiable. Next is not modifiable. So I can't, I end up with a read-only node in the graph to indicate that I can't modify next. And then here's head, no, not null. Here's next alive as well. Next is about to be null checked. And I'm going to return a 1 eventually on that. Hey, quit that, come back. Here's the bang check. Shit. This is probably still the other exit test. Where somewhere I want to say I'm going to get another return of a 1, and it hasn't happened yet. He's still doing. I'd have to follow through the parser, see why all these peeps are getting called here. That did not help either. See, look at the really bad layouts occasionally. And he's got 2 arms where next is null. Or is this control? False from, oh, he didn't put a return in yet. Okay. Here's the second return. Come back of the 1. If next is null, fine. I want to get rid of the damn, it'll quit jumping when I get rid of the last parser scope. So there's definitely some love could happen on the layout enforcement. This comes out of the dot and bad interaction with the browser's fill boxes. I probably need to track where he thinks things are and just hard force him so he doesn't leap about. So there is this program without any parser, and he's got a couple more peeps to do. I would love to say he's going to get rid of these. Why did these not fold up? I'm kind of surprised. Dot next of this. Oh, he can't do it unless he knows that the stored value is not dependent on this. And in fact it is. No, it's not. It's because of the loop. Okay, I understand why it didn't fold up. This one should have folded up, but I can't really, I mean, I can special case the dot I equals. So the answer is I can't fold these stores into the allocation unless I can prove the value being stored doesn't depend on the output of the allocation, which would be prove it doesn't depend on the pointer that's coming out here. So you have to find the value edge out of there. He's not very helpful in putting an edge number. It's going to be this head, which is above the thing. So, some amount of work you could tell that I could fold these two stores into the new. They don't actually change the emitted code any. It just kind of cleans up the graph a little. So there was a null check or two that I didn't have to have. So this is not a good one for the null check guy. Fine. All right, I should be done. Done. Oh, and the one thing I want to mention is WebSocket, because somebody asked for WebSocket, and no, go to the WebSocket. Nick, I'll find this file. Search, yes. Oh, that's really stupid, because it's just exactly right here. So I wrote a WebSocket for Java, and somebody's already asked me on the interwebs for the WebSocket for Java, and it's very, very lame, and someone needs to do some love on it. But this will open a WebSocket. And I couldn't find one in Java that didn't involve an enormous framework. So several enormous frameworks will do WebSockets. And here's a one file, 2-page of code WebSocket. New WebSocket. Give me a path and give me a port, and I'll open a WebSocket. And so I go to docs HTML, and I open a WebSocket on my side. And if I go to chapter 18 docs, index HTML, there's a bunch of HTML, and then way up front here, new WebSocket. Localhost.
What's your API? Just call send and call receive?
Yeah, there's close. And you get frames, WebSockets, you get frames, which I turn into strings, but I could give you a frame API, and you could get a frame left and right with uninterpreted bytes. Right now, I just do it as strings. But that's it. Yeah, having opened a WebSocket on the browser, like if you open a TCP socket on the browser, every security thing on the planet screams at you because, oh my God, you're trying to bypass whatever. It's fine. So the Java side says I have to expect a WebSocket on the browser, and the fucking WebSocket has all this stupid things in it for security. And then once you're past them, it's pretty straightforward. So the web viewer here just says, make me a socket, and then that's creation, so the new JS. And then when the JS run, I'm just while true, server get, that's my program. Get the next string out of the server, it better be a program. Client can politely ask for more frames, but I'm going to ignore and send them all anyhow. If he handed me a null, then I had an empty box. I clicked through, no one cares. Otherwise, oh no, I actually, if you click through an empty box, I declare close. And a bunch of closes I have so that you don't end up with, during debugging, endlessly spawning new windows, because the dude spawns a new window on purpose. To your a WebSocket. WebSocket spawns the browser window, but I could not do that. The run code here just says it's a parser call, make a new parser, fill in some things, set this global to true, show pre-parse, then call the parser. And the parser just says, oh, if show is true, run a dot frame dump and hand it out to this guy. And he calls in here. Hey, you wanted to call show. Okay. Well, I get a parser P handing me his globals. It's all stupid so that there's no hack. It's like all globals. So there's no hack on the parser cogenerator optimizer side. It's like pretty clean. It under the hood says, oh, you want a JViewer show? Then go ahead and call JViewer.show. And here's the parse. So boom. And then this, I know Arthur was asking, but this is just a dot pretty printer for simple. And it's a couple pages. It's based on the other pretty printer we had with a little more stuff on it. Sorry, someone's going to ask?
Yeah, I was saying I already found that And they might get some inspiration for the other IR visualizer tool that I have.
There you go. There you go. There are things to be done with it that I want. The biggest one is to get the high speed forward and backwards to not have the fucking thing. And then the next thing would be to like fix some fixed points at big pieces of control flow graph and not have the CFG nodes swap scopes left and right and shuffle around. I probably should do the scopes off to the right. And there's only ever like 3 at a time. Not true. Ever you get 3 per nested loops. So you might have a bunch, but there's a stack of them. There's a limited count. So I should do something to force them to be nicer. So I don't have to deal with them jumping about. That is ludicrous how they jump about. Fine. Hey Jim, we're all but done here. Unless somebody's got something else to bring up. JS, oh, I was going to show you WebSocket thing, the security in WebSocket. This is like cut and paste from the Mozilla website. So WebSocket just extends server socket. Here I launched the browser at your URI so that calling WebSocket with a URI gets a browser that launches that URI, but it's probably not the right API for the WebSocket. It ought to be the client of WebSocket does the browser. Fine. It's first thing up. You just move it to the client. Then buffered reader, because I got to do the security thing, it's easier. And he's going to send me, the client, that's the browser, sends me this packet of headers. I ignore them all unless it says socket WebSocket key. Then I grab the key. All other headers into the Bitbucket. Magic handshake, totally from the Mozilla website. Cut and clone this code, no problem. Take the key, do SHA-1 digest base64 encode, blah, blah, blah. Like I said, cut and paste from Mozilla website, MDN developer network, boom, done. So that goes back out as a write. And then you have to deal with the reader. And the Git has this frame thing where I don't implement multi-part continuations because my client's not sending me multi-part continuations. And I have a min message length, so I'm going to guarantee some of these gets work. And the get is literally get a unsigned byte. Get a return buffer at masked unsigned byte and advanced buffer. This is a poor man's direct byte buffer, and I'm to do. Just use direct byte buffer. Fuck it. What am I doing this for? And then from a byte here, you have to decode, decide it's 2 bytes or 4 or 8 bytes for your size, and then you're into grab a key, and then you do XOR encoding of the guy's thing, scrolling through the 4 bytes as you go, and then it's a string. So there is another API that I could just hand you the frame as start here in the buffer, go to here. I've already XOR flipped it. You get your bytes. And that's it. You got to get and put. There's pings and pongs, which I don't test, but they've implemented. Puts easier. It just has this 1 byte. High bit means this is the whole message. The low order 1 means it's a text message. Then a 1 byte length and write those bytes. And then if you're big, you have to do 1 byte of magic length is big, and here's 2 bytes of length, and write those bytes. It's a really simple thing. But it's kind of a pain in the butt, and I couldn't find anyone who had a freebie floating around the web. Please give me a 1 file, open a WebSocket at this URI. No. Yes, you can do it. All you have to do is download JBoss, WebSphere, yada, yada, Spring Boot network things. And I'm like, oh my God, 500 megabyte jar file to open a WebSocket. No, thank you.
I built one. I'll look for that.
There you go. Well, I had people asking for it, like open source it and put some, words on it. Hey, here's a dumbass WebSocket, 1 file WebSocket. Like, you don't need more than this for this kind of a hack. I mean, other people may other things, but for this hack, I don't need it. Fine. If I was already doing,
I think that's what a lot of people need is a way to throw bytes back and forth between a server and client.
It makes for a dynamic, fast, interesting, fancy client. Yes.
I took the RFC and put the code in between as the RFC was comments. It worked. I forgot what I named it. I named it the RFC as the class. I don't even know where it is right now.
I can't find it because I was looking for Java, WebSocket, whatever. No. All these frameworks would do it, but something, fine. So I'll throw that out there and say, hey, chapter 18 simple has this. And
I thought really small, clean libraries was the thing that the JavaScript ecosystem was all about.
yes, well, this is JavaScript. I'm with the Java side. JavaScript, the browser comes in with a WebSocket. I didn't do nothing on the JavaScript side for WebSocket. I brought in Dot and GraphViz and something else, not too much.
Yeah, that was going to be
Um,
my question is it worth making sure that your APIs have the same names for send and receive and ping and pong and everything as the web browser?
oh yeah, the names aren't there's hardly any API on the web browser either. So that wouldn't be done. Here I am bringing D3, GraphViz, this third-party library that is D3 GraphViz. That's all I bring in. Then there's a bunch of code in here for doing things like debugging. I said get program on the console and get the value out of docprog, which is what that program was, and throw it in there. Where did I grab the program? Now that's me sending it. That's you edit it. That's render. Messages I receive. Somewhere in the world, I get an on event from my socket. And then I just have this data. This is what came from the server as a string. And if it's a bang, you want a new program, I'll call get program. That'll block till you type something in that box. You're done. I should change my animation so I know that you're at the last frame. You gave me a digraph. Oh, it's a dot frame. Push it on my collection of dot frames and then tell you I ate that one. Give me another one. And then start rendering. And otherwise, all I do is say, oh, I don't know what you sent me and get program. On close, on error, exit. Complain errors, blah, blah, blah. That's the rendering logic. Update is pretty printing the forward and backwards button. That's kind of crazy how much shit you have to do to make that work. Forward and backwards, update in. And if you go forward at the very end, if you have a big guy, you can fast forward to the right, hit the end while he's still loading frames. So this will ensure that when the next frame shows, he'll go ahead and go forward. And this is the swoopiness when you go between two frames. But where the frame lands, that is a collection of two dot frames that's rendering. And somehow he decides that they have a box that's over here instead of centered and middle. And then he leaps fucking about. And all I have this is the entire HTML layout. It's hardly a page. And it just says, program upper left. But you'd expect it to be tiny. Here's a box for your program. And somewhere in here is a box this is the display graph. This is the box for the thing. And God, if he doesn't leap about, and I have no idea why. So I need to replace him with, instead of flex, probably a fixed, and I probably have to go query the element after I fill it in. What is its dimensions and force it to be some sensible place in the middle of the universe. Fine. There are things to be done. It's not tons of code. It was a lot of bit fiddly, nitpicky shit to get the WebSocket. Like I spent at least half a day trying to get a WebSocket open on from the web or a TCP socket. And there were several TCP socket tunnels that were basically announced themselves as cheaters to break security with a TCP socket. I didn't like those either. And then I spent a day making a WebSocket from scratch when I realized I just wasn't going to find one on the web. So it was like 2 days to get to I got a WebSocket open. Then it was 2 or 3 days to get the graphics to come do something sensible. The last day kind of prettied up a bunch of things, except then I discovered it leapt about. Like once I got the arrows working, it took forever to get them to work as you would expect. They're so nitpicky. You can run off the end of the arrows, and then the thing leaps about, and then suddenly the arrows come off your mouse, and then you can't click on an arrow. You're clicking in open space, and he zooms, and weird shit happens to your display, and bad.
I pasted a snip from a non-functional SSL version of what I was doing from 3 years of Neo async hell. If you want to check that out.
Is it a WebSocket?
Yeah, it's a WebSocket with pure Neo
okay,
stateless web server. Like there is no internal state. There's no session.
Right. That's what this guy is. He's no internal state.
Mhm.
So yes, same. I don't do all the things though. Like I I stop at multi-part messages. I stop at 65K, larger than 65K messages. There's a couple other things I don't do. Oh, I have an API that I shouldn't have, which just opens starts by opening a browser because my goal was to open a browser because it's a WebSocket, and that probably shouldn't be done by the WebSocket server. And there was another thing I wanted to not do. Oh, I'm handing you back strings, and you might want to send raw binary data. That would be the purpose. So I
The
should
the
hand you.
amount of functionality you get from one page is excellent. So
Okay, I'll take that as it's a good job. Move on.
yeah, yeah, for now.
For
Unless
now, done.
someone
Okay, website done. Well, we can be done here. Did anyone else want to add? Jim, you missed the whole demo, but I did it like 3 times for people, so you have to go watch the video for the demo.
I'll watch it happily.
It's
Yeah.
eye candy, but that's it.
I went to I wrote the same thing as Netty with like inverted HTTP code that, it just cascades from async to async to Lambda in in a capture
You're talking about
and
the JavaScript side of things.
it's a what?
You talking about the JavaScript side? Because you're talking async.
No, the server side. It's
Oh,
just
okay.
a constant dispatch of IO
You talking about Netty's path,
vectors.
Netty's dispatch?
I didn't. No, I'm far less code than Netty, but it's
Yeah,
so much abstract that it yeah, didn't take over the market.
I see. Yeah, Netty was one of my other options. I was like, I don't want to have my compiler have a Netty server in it. Why? Why does this have to be here?
Netty
Finally.
is the only other quick server source now
Yeah, I
uh,
know.
for
Right.
Web3.
Right.
That's
And I'm like, that's still way too much overhead. I'm writing a fucking compiler. I'm not writing a web server. Fine.
I mean,
so
HTTP3 could also use a tiny library, but
Um, I have to have
but
you have a
how?
Java tiny HB3 library, and that would open up a socket to a browser page.
It's going to be C++ underneath no matter what. Even Netty's doing that.
why?
But not including that in my project. In the case of Java, whatever server socket does under the hood in the Java, I don't care. Surely that goes to some C++ wrapper over the built-in C libraries for sockets on C.
Yeah,
I
there's
don't care.
no analogs to the C++ quick server,
No,
unfortunately.
no, no. Whatever I can get out of the Java side, which, like I said, I can get a simple socket, simple server. That was easy, but making it a web socket required the security thingy, which eventually I just cut and paste my way to victory and then declared done.
so would it be hard to implement to jump from source position to graph?
So in that dots array that I was in the JavaScript side, he has the server's parser point in every dot frame. So the dot frames are a string text that says digraph, and it's a dot text file. And then the second line in is / position equals, that's your comment, that's your parser point. They map 1 to 1, and that's what I use to do the move the cursor around now. So if
Yeah,
you click, you do an on event in the text area of click
yeah.
down and binary search with a funny function that looked at the first header of each of the dot frames for the position,
Hmm.
find the nearest position match.
That would be
That's your
useful.
cursor offset.
That would be useful. It's kind of mini debugger. So
Yeah, right. I'm all happy to have somebody do a PR. I'm gonna make money the rest of the week, and next week I'll be doing other different money things. So, sometime around Christmas I'll probably be doing simple again. If somebody wants to grab improvements to the graph thing, I would love to take them. I will probably next touch simple. I will be doing the actual functions that we don't have. That simple needs a function. So I'll be doing functions. Um, and after functions, I want to do cogen. And actually, the graph thing can work well with cogen as well. I just switched to the ideal graph to the same ideal graph with a enforced layout, and then get a vertical line by line layout, and then machine code for every node in the graph, and blah blah blah. You can get a layout there as well. Somebody has a better graph layout strategy. I'm using the standard dot layout. If somebody knows of this, dot engine has like 12 layout graph choices. If one of them's better for doing control flow graphs in dot, I'll take that. If there's hints I can give them to do better layouts. He does okay on the small, and as soon as they get any kind of large, they get bad fast.
That's all. Some ability to filter something to show you what's most important.
Yeah, and maybe that's just the thing. I like.
Can you do Mermaid? Can you find a plugin to get it far enough?
I
Mermaid.
think Mermaid was one of my choices, but I think it also didn't say that it was friendly to control flow graphs in particular. Dot layout Mermaid. I get layouts of dots of mermaids. Mermaid flowchart syntax. This is probably what you want.
Yeah, they got 1,000 UML doc formats in it.
I see. This looks very dot-like. Is it not using
It's close, but it looks like an improvement. It's pretty
intended to be
visually good.
for
Format
control
good.
flow graphs? This is the key difference. It does claim, woo, I'm all exciting. And I'm not doing flowcharts. You have to be careful because I have cycles, which breaks a lot of these things. That's why you have to not
And
not
the
grab
thing I find with Mermaid is that it expands horizontally or vertically out of control, and you never know which way until you see it.
Exactly. Well, I get vertical expansion and dot out of control, except for the scopes, which go sideways hugely out of control. Um, oh, here's a thought. I wonder if I should turn my scopes 90 degrees and run them sideways. I wonder if they would look better.
Yeah, that works good in Mermaid.
Oh, interesting.
But you don't know until you see it. Like it's just so arbitrary.
Right.
It's either right, left, or top to bottom, and you don't get any. You have to make middle rectangle, lily pads to hold them in a sort of order.
I see what you're saying. Yes, I'm doing things in dot to hold groups like the scopes are forced into that boxy shape. And I could shrink them this way fairly easily by getting rid of my counter 1, 2, 3, which is another dot piece into some sort of text annotation. And that would shrink them, it would help. But I think if they went vertically, they might have an easier time not caring. Or another one would be like, I want to not worry about crossing edges. Like he gets hypersensitive about crossing some edges, and they do ludicrous things to avoid crossing just one more guy. And like at some point, I'm like, no, you're a dotted edge from a scope. You're not supposed to block the IR. You're just supposed to sort of hint where you come from. Just go underneath and go dim and go straight. And maybe that's the right answer there. I need to say this edge shall only be a straight line and it crosses or don't count for crossing. And I might be able to say something. Anyhow, there's a bunch of layout things in dot. There's a million layout options, and I filled with many of them a lot. And I'm up to where I'm at now, and it's better than it used to be for small things, and then large things it gets ugly.
D3 is like the best, but it takes like 2 weeks to make one perfect, and the AIs have no chance. It is
Well,
so
this
hard.
is D3 dot. This is D3 and GraphViz combined. GraphViz draws an SVG on its own. Oh, you think you use D3 directly?
Yeah, that's
That's interesting.
incredible, but it's not cheap, technical
Right.
debt wise. You get fiddling.
That's a good point. The effort I go to make dot work, um, you can imagine replacing all those calls to an appropriate version in D3 for the same game. I did look at D3 for a while up front. I couldn't find where it was happy with like control flow graph like things with cycles. Um, I don't
It
know.
has a really good force directed, but then there's not there are many good examples of it. And then it goes crazy into the other geometries.
Yes, like I've had a lot of cool geometries that are like, that's nice, but that's not a program. Sure enough, that looks really cool, and it's nothing I'm doing. Fine. All right.
There's no reason to suspect your program's going to be planar, though.
There's some stupid, yeah, no, but there's some stupid theories that says register allocation graphs on SSA form are in fact planar. And then you can do something with that in the register allocation strategies. I don't know if that applies here. So I think the right answer is I'm not going to be planar. You're correct. In fact, I am just fucking going to have cycles and they're just going to overlap and deal. I do tell D3, not D3, dot, that I have a back edge and that gets away from him trying to like, I'll just spin this a little bit more to get these edges to not go upside down. Says, no, these are back edges. They should go upside down. After that, like I said, he's good in the small, and as soon as it gets large, he goes crazy. Dot. Now, is D3 going to could do better? Do I want to burn 2 weeks of my life finding out if D3 could do better? Oh, I'm just going to say, given two different dots, and I want to place them, I want to, first time they did the weird honk jerk, I want to go debug that one and say, what the hell did you do? and fix that. And it could be that I can make control flow graphs do better by picking out the control flow graph portions, forcing dot to do a reasonable layout on the CFG, then adding in all the data edges without moving the CFG around. Like, I know things when I look at that CFG, like I have pre-order numbers, I have reverse post order layouts. I can somehow tell dot, you're going to lay it out top to bottom in reverse post order. Something like that. Loop nested, smart, reverse post order, top to bottom. So it's like a full come out of graph format into linear format almost kind of thing for each layout. But it might be necessary to get dot to like behave. Anyhow, these are fun things because it's eye candy, and if you fiddle, you get immediate feedback. So I had a good time doing it, but I gotta do other things now. All right. Done. Anyone else? Gonna call it. All right, folks. Until we meet again. And like I said, I'm all happy to get pull requests for updates or improvements on the graph thing. That would be fun. Bye-bye.
Bye.